Next, we will discuss another measure of relative standing that allows us to rank each observation in the dataset. An alternative way to measure the relative standing is to compute the percentiles. The pth percentile is a value that separates the bottom p% of the data from the remaining values in the top of the data. To find the percentile of a particular observation, we use the following formula. For example, consider the following population. Before we proceed any further, make sure that the data is organized in ascending order. The percentile of the value 76 is the number of values less than 76, which is 2, divided by the total number of values, which is 5. So the ratio is equal to 0.4, and after we multiply it by 100, we get 40. So 76 is the 40th percentile. To find the pth percentile of a dataset, we use the following formula. In this formula, n is the size of the dataset, p is the desired percentile, and I is the index of the observation that we are trying to find. For example, consider the following population. Before we proceed any further, make sure that the data is organized in ascending order. So to find the 30th percentile, we use the formula. We plug in 30 for p and 5 for n, and we compute the index as 1.5. After rounding it to 2, turns out that the 30th percentile is x2, which is 73. Certain percentiles are particularly important. The deciles divide a dataset into 10 equal parts. The quartiles divide a dataset into quarters, which are 4 equal parts. Quartiles are the most commonly used percentiles. A dataset has 3 quartiles, which we denote Q1, Q2, and Q3. The second quartile is also the median of the dataset. Now that we know 2 different ways to measure a relative standing for every observation, the question is, which one is better? Percentiles usually give a more accurate and meaningful measure of relative standing than z-scores. However, to compute the percentile, one needs to have access to the entire dataset, while to compute the z-score, one needs to know only the mean and the standard deviation of the data. With very little information, z-scores provide a feasible alternative to percentiles for measuring relative standing. For example, for a student to be able to compute the percentile of their exam score, the instructor must allow the access to the entire list of scores, which is impossible. But to compute the z-score, the instructor must share only the mean and the standard deviation, which is something instructors are more comfortable doing. We discussed how to compute and interpret the percentiles, the alternative way to measure the relative standing of an observation.